Morning. So we're gonna, this is our last lesson for the semester, last lesson for rational expressions. We're drafting them today. Kind of got a little sneak preview of what that's gonna look like last time as well. So they take a while. Like I said, I'd like to get through at least 3 examples with you today, so we're gonna try to move a little bit quick. But this is all the steps you have to go through. This is why it takes so long. Now, I don't want you guys to write this. And the reason why is because you're gonna write it as we go anyway, so there's no point. But just to kind of give you a nice overview, the first thing that I'm going to ask you guys to do is determine your end behavior. Now, that's the lesson that I left with you guys in the sub on Monday. I was looking through your homework. A lot of you guys seem to grasp the concept fairly decently. So basically, you're going to find your end behavior, and once you know that, you can find a horizontal asymptote if there is one. Then you're going to find the Y-intercept if there is one. Then you're going to factor your polynomial at that point. We don't like it factored for the first 2 steps. It works kind of nice the way it is for these 2 things. But for the rest of the stuff, we like it in factored form. So we're going to factor it. We're going to see if there's any holes anywhere. We're going to see if there's any X-intercepts anywhere. We're going to see if there's any vertical asymptotes anywhere. And after we do that, we may be able to sketch the graph. You may or may not have enough information at that point. At this point, you would have enough information to graph this because it has to squish against this asymptote. It has to squish against this asymptote and has to hit that point. There's only one way that's going to happen. Over here on this half, it has to squish, squish, and hit. So it's got to be something like that. And you've got your graph. That's the hard part. Hard part for people is sketching it. So what you can always do is just find more points, okay? So if you're kind of insecure about where to draw the line and what shape should be, just plug in more points to get more. And that's kind of what we end up having to do. Sometimes you don't have enough information and you have to kind of plug in more things. So for instance, here's one that I think we're going to see. Oh, I didn't want to do that. Here's one that we're going to see later on today. You know, we're going to have something like this. We'll get these 2 halves over here, but something's going on in the middle here, and there's a lot of things that are going on. It could be a U shape like that, or it could be an S shape like that, right? And so since we're not sure, we would have to pick some points over here and here to see which way that graph is going, because we won't be sure. So step 7 is an unfortunate step. It's the hardest one. On a multiple choice test, which this is, if you guys do steps 1 through 6, you're probably going to get the answer anyway.
I missed that. Could you say?
Yes. If you did 1 through 6, you'll probably get the answer anyway in a multiple choice test. But drawing it freehand, you'll probably find that's a little bit challenging, step 7. But we'll practice it. And I don't want to talk too much more about this, so let's move on and actually get started on an example problem here. So, would you guys, I don't want to do that one yet. I want to start off with number 1. Would you guys write down this problem here, please? But thank you for your kind apology. All right. Okay. So for the first step, you guys, we're going to find the end behavior. Now, if you had a hard time with Monday's lesson, this will be a nice little review for you. But basically, to find the end behavior, we're going to find the limit at infinity of the first 2 terms, right? Did you touch my computer shop? Mm-hmm. You sure? Mm-hmm. All right. And then we reduce that. So x squared over x squared, that reduces to what? -1. And what is the limit of a constant number at infinity? or what is the limit of 1 at infinity? It's just 1. Whatever number it is, that's the answer. Yeah. Oh, you're right. It would be negative. Thank you. I think a few people were trying to mumble that at me. I didn't quite catch it. But yes, you're right. Now the same thing is true for the limit at negative infinity for these ones. So whenever you just get when you actually have a horizontal asymptote, which is what this is, by the way. When you actually have a horizontal asymptote, you don't need to do positive infinity and negative infinity. You're going to get, it would be the same thing on both sides. Okay? So there's that. Let's go ahead and graph that. So if you haven't already sketched a graph, go ahead and start sketching one, and let's all draw a horizontal asymptote at y equals 1. So I know this much about my graph is that it can't cross, it's going to get flat up against that horizontal asymptote as we go further out to the right and left. Oh, we should probably title our steps as we go also. So let's do that. End behavior / horizontal asymptote. I would highly encourage you guys to label your steps as we go, because those were the steps that I told you we were going to write down as we went. Pass around homework to them too, as much as a picture of it. All right. So I'll wait another 30 seconds. You guys should have your information there in the graph going. Okay. The next thing we're going to do is we're going to do our Y-intercept. So that's going to be our label for the second step. Let's find our Y-intercept. The Y-intercept will be those two numbers over each other, right? So I know it's going to hit the y-axis at -4. That's something that we learned yesterday. So I know that it's going to hit the y-axis at -4. While you guys are writing, I'll remind you why it works that way. Y-intercept is what you get when you plug 0 in for x, right? So if you plug in 0 for x, everything goes away except those two numbers. The next thing we're going to do, guys, we're going to factor it. This step will take you guys a little bit of time, depending on your factoring skills. I'm not going to spend too much time talking about factoring today. I'm just going to do it. But if you guys, when you do your student practice, if you guys end up having any questions about factoring, let me know. +3, -4. So that's going to be the third step, is you're going to factor it. So I'll let you guys copy that. We're factoring the original problem up here. Yep, top and bottom. Top and bottom. All right. Step 4. We're going to find the holes. The holes are where the factors are identical on the top and bottom. So we're going to cross that off. And then we're going to set that factor equal to 0 and solve. So I'm going to have a hole at x equals 1. How did I get what, buddy?
X minus 3.
I factored this. And once again, I'm not showing my work for factoring right now, but when you guys do a problem, if you have a question about factoring, I'll be here for you. But yeah, it's just it would be the box method to answer your question. Yes?
For factoring, I got X minus 3, X minus 4.
Where at?
On the top.
Oh. Really? Sad times. We got to back up then.
It is 6 times 7.
Mr. Bailey, Mr. Bailey. So, Quinn, you said X minus 3 and X minus 4?
Yeah.
You right. Mr. Bailey's a bad person. But on the bottom, I was correct, right? It's X minus 3, X minus 1, right? Yeah. Okay. Sorry about that, guys. Lo siento. Which is going to change step 4 as well, so I'll wait for you guys to make your correction there. Ah. We got it. We have eyes on this. Smart kids watching out for things. This is good. All right, so that's going to change step 4. So now where's my hole going to be located at? Yeah, we're going to use that factor now instead, right? It's going to be X minus 3, which gives me 3. Thanks, Quinn. Good catch. Good looking. All right. Now, we can't graph the hole right now. The hole is something you have to do at the very end once you already have your graph done. But it's nice to find it at this point because it's just kind of convenient in the process. Bless you. All right, so the next thing we're going to find, guys, we're going to find the X-intercept. So let's do that. Need some writing space. Okay, so we're on step 5. X-intercepts is next. Yesterday we talked about how if you want to find X-intercepts, you take the factors from the top and you set them equal to 0. And then you solve. So I have one X-intercept at 4. So I'm going to put a dot on my graph at 4. You guys can do the same. Put a dot on your graph on the x-axis at 4.
And then if there's 2 points, we mark those 2 points.
Yeah, yeah. However many you get, you would put all of them on there. All right. Okay. Okay. Step 6. We're going to find our vertical asymptotes. Okay. To find your vertical asymptotes, you take the factors from the bottom and set them equal to 0. Notice I'm not using the ones that I crossed off, by the way, right? Because that was a hole. We don't use those. So I have one vertical asymptote at x equals 1. So let's draw a vertical asymptote at x equals 1. Okay, so at this point, you guys, on this graph, you actually have enough information to sketch a graph. Here's why. I know that the lines that I draw, they have to hug up against the vertical asymptote and the horizontal asymptote. And the lines that I draw also have to hit that point and that point. Okay? So, hug that asymptote, hit that point. There's only one way that's going to happen. Okay? Same thing down here. Hug this asymptote at the far right, hug this asymptote. It's Shaw. It's you, Shaw. I know it is. Hug this asymptote at the far bottom, hit that point. And there's your graph.
So all you do is just hug it.
Yep. Yep. Now sometimes though you don't have enough information. On this one we did. On this one we did. But we're still not done. Does anybody know why? What? Well, it rhymes with, you said no, so that rhymes with the answer I'm looking for. The hole. We got to put the hole on there. Where was the hole located, you guys? At 3? So can you guys find, put your finger on your graph where x equals 3. Can you find on the line where x equals 3? That would be right there, wouldn't it? So we're going to put an open dot at x equals 3. There's a hole in our graph. And that's that. All right, so a lot of steps there. This isn't a practical thing to do, by the way. You know, as a mathematician, it's like, if I wanted to graph a rational expression, in all honesty, I would probably just use a graphing calculator. So why am I doing this to you? Well, because every step is valuable here. It's always valuable to know how to find an X-intercept. It's always valuable to know how to find a vertical asymptote, especially in calculus. Holes are important in calculus too. So every one of these steps are really valuable. It's just, I'm just giving you a package deal where you put it all together and you can create a graph. But really, if you want to graph these, it's obviously too tedious. Much easier to just use a graphing calculator or something. But there's a lot of valuable stuff in this exercise, so it's worth doing it. All right, so I'd like you guys to go ahead and do this one. Go as far as you can. I'm going to give you about 5 minutes for it. Do as much as you can in 5 minutes. Okay, now, I bet a lot of you guys who got this far got this part just fine. Right? Don't forget your hole. Where was the hole at? It was at 2. So I should have an open space like right about there. Okay? But we're actually not done. There has to be more to this graph. Okay? There has to be something over here. Okay? Graphs always go to the left and right forever. So it can't stop here. It has to go on. Which means that you have 2 possibilities. And you actually can tell, but in a sneaky kind of way. So let me ask you this. Is it possible for it to go like this? But is it also possible for it to go like this? So we don't know which one it is, right? But there actually is a way you can tell. Yeah?
But why do you have the vertical asymptote up 4?
Because I did the work and I didn't look at my phone for the first 5 minutes of this problem. Butthead. Because you set this equal to 0. The bottom equal to 0. All right? Now, there actually is a way you can tell without having to do a test point. If I did this, you guys, wouldn't that have to hit the x-axis? And what would that be? That would be another root. But I don't have any more roots, do I? I only had this one. So if I had it up here, it has to go down. It has to hit the x-axis so it gets close to that dotted line, right? But if it did that, I would have another root. But should I have another root? No. So where should this line be? It has to be underneath. Now let's just say that, you know, if you guys want another way to tell where to draw your line, because really you only have 2 possibilities, right? Top or bottom for that curve. How do you know where it goes? Well, what you can do is just pick an x over here. So pick an x value on this side of the graph. Give me one. 5. Okay, 5's right here, right? If you plug in 5 up here, work it out, see what you get. If you end up with a negative number, that means you're down here. The y values are negative. If you end up with a positive, it's up here. So that's what I mean on step 7 by, if you're not sure where the curve goes, do a test point. Just pick something over here, plug it in, and see what you get. But here, I'm not going to do a test point because I know that if I did the curve on the top, that would give me another root, which I know I shouldn't have. So I know it has to be on the bottom. Okay? All right, so that's number 1. Let's do another. We're gonna do. I'd like to get through 3 of these today, at least 3 examples. It'd be nice if we could do 3 student practices as well. But let's write down this one. We'll call this example 2. Example 2. Okay. I'm not going to label my steps this time. Okay? I'm just going to, I hope you guys wrote those down the last one so you kind of have some steps now in your paper. In the interest of time, I don't want to keep doing that over and over again. But we are going to follow the steps. So the first step was end behavior, right? So that you can find your horizontal asymptotes. So we do the limit as x approaches infinity of the first two terms. Now somebody asked me a question, by the way. Two people asked me this question. They said, don't we sometimes do negative infinity? And the answer is yes. You do negative infinity if there's no horizontal asymptote. And I hope to get to that example today. But this one, you'll see, actually has the horizontal asymptote. So positive infinity is good enough. I'll explain why you don't need to do negative infinity in just a minute if you have a horizontal asymptote. So let's do it. So the next thing we're going to do is we're going to reduce this, right? So that's going to give me the same thing as this, right? And what did we talk about? 1 over x to any power as you go to infinity is always what? 0. That's a horizontal asymptote. If you get a number here, like on the last one and on this one, you've got a horizontal asymptote. And you don't need to do the negative infinity. Here's why. First of all, let's draw our horizontal asymptote. I'm going to use dark green here just so we can see it a little bit better. Here's why. When you have a horizontal asymptote, your graph has to be doing the same thing on both ends. As I go to the right, it has to squish up against that green line, and as I go to the left, it has to squish up against that green line. So it's going to do the same thing on both ends, so there's no point in doing positive infinity and negative infinity. They're going to be the same. But when you don't have a horizontal asymptote, they could go up and down, they can go up and up, they can go down and up, we don't know, so you actually have to do both sides, okay? And hopefully we'll get to that example a little bit later on today. All right, let's continue. Number 2, Y-intercept. A lot of these Y-intercepts are kind of lame. It's negative 4 over negative 9, which is 4/9. If you guys had to estimate what 4/9 is as a decimal, what would you guys say that's about? Huh? Yeah, pretty close to a half, right? So let's just put it at about a half there. Number 3, we're going to factor it. The top, you can take out a -1. I don't know if it's really necessary. I think it would have been fine to not do that. How about the bottom, though? How do you factor that? That's a difference of squares. Okay. So, step 4, do I have any holes? Nope. Step 5, what would my X-intercept be? Well, it's x plus 4 equals 0, right? And so it's going to be -4. So I'm going to touch the x-axis at -4. Okay. By the way, this is a nice moment to mention this. I think it was yesterday, although I don't expect you guys to remember this necessarily, but I'll refresh your memory. Yesterday, I talked about how you can't have a dot on your vertical asymptote. You remember that? You're not allowed to touch a vertical asymptote. You can touch a horizontal asymptote. That's okay. Horizontal asymptotes don't tell you anything about the middle of your graph. They just tell you what happens at the end. That's why we use infinity. That means my graph has to get closer and closer to that line at infinity, but it can cross it all day in the middle. Vertical asymptotes, though, those are places where your function is literally undefined. You cannot touch a vertical asymptote, okay? So I can have a dot on that green line. That's actually allowed, okay? All right, let's continue. So I've got a X-intercept. No holes. Let's do a vertical asymptote. what would that vertical asymptote be? 3 and -3. Right? If I set both of these equal to 0 and solve, I'm going to get two vertical asymptotes, one here and one here. So let's draw those on them. So you're not allowed to touch a vertical asymptote, but you can touch a horizontal one. Okay, now this problem here is somewhat of an issue, okay? I can tell you right now, I have no idea how to connect any of these together. Let me show you why I don't know. It would have been nice if I had a dot up here, because if I had a dot up here, then I know it would go like that. But I don't have that, okay? Or if I had a dot down here, it would go like that. But I don't have that. I've got a dot right on the line. So what I need to do then is I need to plug in a few extra points to figure out what that side of the graph looks like. Okay? Over here, same thing. I really don't know if it does this. That's one thing it could do. It could also do this, though. And it could also go the other way. I have no idea, so I've got to plug in some more points to find it. Over here, same issue. I don't know if it's up here or down here. I'm completely clueless. So I have to do some test points. So let me show you guys how I do this. This part is a little bit different. This is kind of a new thing. So I think the easiest side of the graph to start on would be this one over here. So let's start over here first. Give me an x value from this side of the graph. Okay, 4. Let's do 4. So I'm going to test 4. Okay? If I plug in 4 here, guys, will this come out to be positive or negative if I plug in 4 right here? 4 plus 4 is the negative I got here, but 4 plus 4 is 8, right? So that's going to give me a positive in there, right? How about down here? If I plug in 4, what will this parenthesis become? That's a positive as well. If I plug in 4 here, what do I get? Okay. What do you guys think the final answer would be if I had a negative times a positive divided by 2 positives? The final answer is negative, right? So if I have a test point of 4, I get a negative, which means, is it going to be on the top or bottom? It's going to be on the bottom. So that's how you do it. Now, could you actually get a number out of this to graph, like actually find what is the y value? Instead of just looking at the signs, actually plug it in and get a number? Yeah. But a lot of times they're going to be nasty fractions, and I say just get the signs. It's easier. Okay? So that half's good. Let's do this one. So on this one, I don't know if it's a U shape or it's one of these weird little curves here. So we got a little bit of work to do here. You're going to need to do a test point between here and here. Okay? I want to test here to find out if it's above or below, and I also want to test here to see if it's above or below. Okay, so let's do it. Let's do a test point of 1. Let's try 1. So if I plug in 1 here, what do I get on the top? Here and here. 1 take away 3 would be negative, right? So what would this come out to be? A negative times a positive divided by a positive times a negative. Right. So that means it's going to be above. So on this side of my graph, I know this much. It's going like this. It's above the line at positive 1. Now the next question is, does it curve back up and stay positive, or is it curve down and go negative at that point? Actually, you know what? I think we know the answer to this. And actually, I didn't need to do test points at all here. It's the same rule we talked about last time. Remember I said it couldn't cross the x-axis again in that last problem we did? It can't cross the x-axis because are there any roots in here? So which way does this have to go? Up. I didn't have to do, I was kind of me just being empty-minded there because it couldn't have done anything else. It has to do this, otherwise it would have crossed the x-axis. So I guess I was a little short-minded there, but you guys got the idea. Hopefully. Yep, yes we do. On this side I'm a little perplexed. It could go like this, because it has to squeeze up against that asymptote. It can kind of do that little number there. Or it could go like this. So what do you guys think would be a good test number to try? 7? All right, let's try 7. So, oh, it's -7, right? Okay, so what will this be? If I plugged in -7 here, what would I get? Negative. If I plugged in -7 here, what would I get for this one? In here? I've got 4 negatives. Will that come out positive or negative? Positive. Right? So it's going to be up here. So which situation was it? Is it the one where it starts down here, hits that, and then squiggles down? Or is it the one that starts up here, hits that, and then squiggles up? Does it start up here or down here? Down? I agree. Here's why. Because if you started up here and it hit that point, the only way it could get positive again is if it crosses the, which you're not allowed to do anymore, right? Because if you did, you'd get another root, correct? No more roots. So you're not allowed to cross that x-axis. You can only hit the x-axis here where our root was originally. Okay? This was a hard one, just so you know. This one's a toughie. I think this, because we had to do a lot of test points. I think the hardest part of these is sketching the curves, doing test points. That's a tough thing to do. The first 6 steps, hopefully you guys have that down from our last few lessons. This last one where you have to do test points is kind of tricky. All right, so here's one for you guys. See what you can do.